Welcome back to some more geometry. Today we are looking at 1-5, locating points on a number line. As a warm-up, we kind of look at this. Hey, what's the distance between -3 and 4? Many people just count over and say 1, 2, 3, 4, 5, 6, 7. And you won't be wrong. It is 7 units away. Now, mathematically speaking, when we're doing this, you will do where we ended minus where we started. In this case, we got 4 minus a -3. Now remember that those change the sign right there, so we're getting a final answer of 7 units. Again, that was correct. But what about coordinates that are halfway between? Many people will say, all right, so I count, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So it's 12 units, so halfway will be 6. So we'll count 1, 2, 3, 4, 5, 6 units. So that's the halfway mark. I want to look at a number line. That's actually a really good way to do it. But this right here, this halfway or 1/2, kind of leads to today's information we're talking about. We're talking about a fractional distance on a number line. If they ask you, hey, like I just did, what is halfway or 1/2 between these 2 points, or a third or a fourth, this is the best way to kind of look at it. So hopefully you can see this. It takes it into part. This is the whole formula right here. So we'll write that out. So our formula is x1 plus a over b, that's our fraction, times x2 where we finished minus x1 where we started. So look at it, we first find our distance. That's what the x2 minus x1 part means, is find the distance between the two. Then we're going to take that times the fraction that we're expecting to be away from. So if our last problem, we were at 1/2. So we did, what was our numbers? So we had 7 and -5. So kind of relating this, that we had 7, 5, -5. So we did 7 minus a -5. And we ended up getting 12. So then we said, all right, we're doing 1/2 of that. So we're doing 1/2 or halfway of 12. We end up getting 6. So that's when you were 6 units away. Excuse me. And then we added that 6 to our original starting point. Our original starting point was -5. So we do -5 plus that 6. That's what we get 1. 1 being the halfway mark. So on our problem back here, 1 was our halfway mark. So let's kind of look at this in a different problem right here. Same issue right here. We're looking for a B that is halfway between A and C. So this is our x1, this is our x2, and of course this is our A over B, our fraction up here. So as we do this, we'll say our x1, -5, plus our fraction, 1/4 times x2 minus x1. Right here. So we're looking for 1/4 this time. So 7 minus the -5, that gives us a positive 12. So we're getting 12 in the parentheses. We're looking for 1/4 of that to add to our -5. So if you're not remember how to do fractions, remember the bottom number is trying to divide. So it can divide, 4 can go into 12 3 times. So then we got -5 plus 3. We end up getting the answer of -2. So this value -2 right here is 1/4 distance from A, and it's again a 1/4 of the way from A to C. So this is a problem you tried yourself on in the class. So if you want to pause and try that, go ahead. But we're going to look at this. So this now is our x1. So we got -1 plus our fraction 3 over 5. And then we are doing then 9 x2 minus a -1, which is our x1 right there. Signs change right here, so we end up getting a positive 1. So we got 10, parentheses 3 over 5. We're going to add that to -1. 5 goes into the 10 twice, and then 3 times 2 gives us a 6. Now we got -1 plus 6, we end up having a 5. 5 is 3/5 away from A towards C here. And I know I put B, it should be C right there. Alright. So there is a problem on the homework, and I'm going to go ahead and talk about it right here. Imagine though, this time you're looking for the fraction. They give you the answer, they say 5 is the thing real quick. So as we do this, we'll say, since we know the answer is 5, and this time we're going to look for the fraction A over B, we're going to say 5 equals our x1, negative 1. Now we don't know the fraction, quote unquote. That's what we're trying to find. So we're going to just say a over b here. And then we're going to do 9 minus a negative 1. I use this example so you already know the answer is going to be 3 or 5. So let's see how you would do it in the homework. Because in the homework it asks you what's the fractional value when you know a certain point at a certain spot between two of those points. So these are my 2 points. This is a certain point between those 2 spots. I think this is like problem, it's one of the first couple ones. So as we do this right here, we'll say 9 plus a negative 1, that becomes 10. And then we got a over b minus 1 equals 5. So then you ask, how am I going to get a fraction by itself? Good question. We're going to go ahead and add the 1 to both sides here. So we're getting 6 equals a over b times 10. And just like any other number, how do I get rid of this 10? If this was x times 10, I would divide. Just because this is a fraction doesn't mean the math is still not the same. You're going to divide by 10, you're going to divide by 10. Here, it cancels, leaving me 6 over 10 equals a over b. Now remember, we are going to reduce that, so we get 3 over 5. That's our answer in this particular problem right here, which we knew that already, but that's how you would do it if you come across that problem. Now the other type of locating point is when you're given a ratio. The ratio is in the form of m colon n. M colon n. So this is the m. Whatever's in this spot is an m. Whatever's in this spot is an n. So right here we got 3/4. This is my m. This is my n. 3, 4. Alright, so the formula, as you can see right here, let's make it a little bigger, is n x1. So you're going to multiply the value of n times x1 plus the value of m times x2 all over m plus n. Alright, so here's my x1, here's my x2. Let's run it through this little system right here. We're looking for a ratio of this number line such that it goes from a to b and b to c. This is a 3 to 4 ratio here. So let's set this up. We're going to use n. This is where a lot of confusion happens. We put the n value 4 times the x1 value, negative 5, plus the m value, 3, times the x2 value, which is 7, all over 3 plus 4. Alright, so we're going to having negative 20 plus 21 over 7. That reduces down to be 1 over 7. And that's okay to have a fraction. So this particular value will be somewhere right there, just barely past the 0. So try this one yourself. You're going to get a fraction as well. So we're looking for some p-value that's between a and f. This being my m, this being my n. Same issue here. So we got our x1 and our x2. Just because there's no number here doesn't mean this is not a value. It's just 1 in our problem right here. So let's try that out. So remember, you're going to use the n value, 3 times the first one, x1, negative 16, plus the m value, 1, times the f coordinate, x2 coordinate, which is 1 as well, all over 1 plus 3. We end up getting a negative 48 plus 1 over 4. Now you simplify that, you get negative 47 over 4. You reduce that, you end up getting 11.75, negative 11.75. Hopefully you get the same answer, and that's it. If you guys have any questions, feel free to ask. Bye.